Welcome. Here a talk about taking back control of the software running on your hardware by André, Vadla, Ravnås, and Karl Trygve Kalleberg.
Thanks. So I'm Karl.
André.
And we're here to talk about reverse engineering tools as a means to taking back control of some of the closed source software that's usually running on at least some of the hardware that you carry around. So Frida, he's the author of Frida.
These days I'm working for Now Secure, where we're using Frida for automated security testing on mobile apps. So it's kind of reverse engineering as well.
Right, I'm Karl. I'm Ole's trusty sidekick on this project. I've been contributing on and off to the project for a few years. Also a sporadic contributor to other open source projects, including NixOS and Spoofax, and I used to be a Gentoo developer back in the day when Gentoo actually, for some people, was cool. I'm doing mostly back-end development these days. So Frida is a dynamic instrumentation toolkit. There are many ways to describe Frida, but that's one sort of enterprise-friendly way to describe it. It can be used to inspect and instrument live processes running on your machines. And when I say machines, we're talking about, for example, a desktop computer or a server or a phone or other sorts of embedded devices that run on iOS, Android, QNX, or even embedded versions of Windows, but not Windows embedded itself. With Frida, you can execute instrumentation scripts. You can write scripts, actually in JavaScript, for being compatible with sort of the popular hipster person in this day and age. We need to have a JavaScript interface, and you can use JavaScript to instrument and write your own sort of on-the-spot debugger inside of processes running either on your machine or on some remote machine.
And I should just add that if you really like to write things in C, you can, because the JavaScript is just runtime is just a binding for the C implementation that we have. So you can also write it in C if you really want to.
Right. So if you do that, then there's a little bit of work to get the debugging part that you wrote in C into the process. If you're writing it in JavaScript, then we can fire off the script that you have into the process, and we execute it inside the process that you're debugging in a JavaScript interpreter that we injected into that process. We'll talk about the details about that a bit later. Of course, Frida is open source, so it's licensed under this weird license called WX Windows Library License, which is a very, very, very close relative to the LGPL, but it has the so-called linking or class path exception. So, anybody remember the action replay for the Amiga back in the day? Yeah. Right. So, happy news, we built one. Not physically. So let's show you a demo how a software version of this thing could work in this day and age.
Right, so I have a phone connected here, and I'm just gonna run a game. It's a demo app that we didn't write. It's just it's like a small cute game here, and we're gonna use Frida to attach to it. So what we're gonna do, Fox. So we're gonna attach to the Fox Objective-C process here on the phone. Okay, we're in. And we're gonna just get hold of the character, so the player. Yep. So so what we're doing here, we're just scanning the heap. To go into technical details briefly, we're just scanning the heap, looking for instances of this APL character class, Objective-C class, and then we assign it to a variable. So here we have the character. Don't worry too much about the technical details. We'll get more into that later. And when we have access to the character, if you pay attention to the fox on the right here, we can do like catch fire. And you'll see that it starts burning.
There's no smoke here.
And now it will run a bit faster and has fire behind it.
Right. Not a happy character.
So we can continue. And then now we'll get a hold of the game view controller. Because we've been reverse engineering this app a bit, so we know a few of the internals. So in this game, if you get 3 flowers, you win. Okay, so on this controller, we could call a method set collected flowers count. And if you pay attention in the game upper left corner now, and now I'm going to run this, you see that we collected the flower.
Easy peasy.
And we collected 2 flowers. And, well, 3. And we're winning the game.
Woohoo.
So
yeah, exactly like the actual replay back in the day, right? But I guess what's worth mentioning is that the stuff that you're seeing comes from the phone. So it looks like it's running on the computer, right? Everybody thinks perhaps that's a computer game on the computer, but that's just a remote recording from the phone itself. So if you show the phone,
yeah,
that's what the app is running.
Yeah, sorry, I should have mentioned that.
Yeah. So we're using the computer to debug live into the application running in a super sandboxed environment. That is the iOS application sort of system.
It happens to be a jailbroken device, but it doesn't have to be. You could repackage the app with Frida and do the same thing.
Yeah, on the subject of jailbreaks, we'll look at that a bit later. But as some of you might know, if you have a jailbroken phone, there are a bunch of apps that don't work. They detect that you have a jailbroken phone and they stop working. But there are ways around that as well. Good. So I guess a few sort of a quick question, I guess. How many people here do programming or have experience with programming from before? Yeah, most of you. Any of you program low-level languages such as C or assembly or something like that? That's so people seem at least familiar with it if they don't program it. So there's a highly technical audience then. If anybody thinks we're not going into enough detail, ask questions. If people think we're going to too much detail, ask questions or give feedback or, I don't know, finger or something. And I will try to adapt. So I guess very, very briefly here, I'm going to explain on a high level how Frida works. So on the left-hand side, there's a box and it says Frida, and Frida is a collection of tools. Usually, you can think of it as the sort of GDB kind of thing, running on a machine. So in this case, it's running on this particular laptop. And then there's a red line, which symbolizes either process separation, so you debug into different processes on the same machine, or a process and a machine separation, in which case you can debug into a process running on a different machine, for example, this machine over here. We use the operating system facility to hijack a little bit in the target process. That works slightly differently on every platform, but basically there are usually APIs where you can attach to different processes and start fiddling about a little bit with them. And that's what we're doing. So Frida uses those APIs, depending on the platform, to take a hold of the target process. For example, the Fox game application that we saw earlier. And then we put in a small bootstrapper there in the memory. So we will allocate a little bit of a heap space, and we make our own bootloader. And then we hijack one of the threads in that target process, and then we have that thread execute the bootloader, like so. And then that bootstrapper that loads the Frida agent. So in this case, it's well, the .so seems to imply that we're running a Linux-like system, and that's how it will work there. It will be dilib on an iOS system, or will be a DLL on Windows. And that is where we get our library of Frida into the target process, and then we can do all sorts of tricky stuff with that thing. And one of the things that the Frida agent does is to establish a connection back to the Frida host process, if you will, running on the developer machine. And then we have a bidirectional communication channel, and then we can do whatever we want. What we usually do is that we create our own thread at that point that is owned by the Frida agent. So we release back the thread that we stole to boot, and then the application doesn't know what's happening. So the application could, if they were very, very sort of attentive to what happened, they could notice perhaps a little bit of hiccup, or one of the threads was halted for a couple of microseconds while we load. So it's super difficult to detect.
But however, that's only on Linux and
right.
Android. On the other OSs, there's OS APIs for spawning a new thread from the outside, so we do that.
Exactly, yeah. So it's even less of a detection risk, as it were. So, okay, so that's the setup, basically. That's how we get in. Now we have a thread in there. We have a bit of memory we can play around with. We can execute stuff. And inside of the Frida agent, there is a JavaScript virtual machine that we can send JavaScript to, and then we can do all sorts of really interesting things.
Sorry, I'm just curious, what JavaScript VM are you using?
We have two different ones, or we're using duct tape by default, which is a really small one that also works great on embedded, where you have limited memory. And we have V8 as another option.
V8
if you
is huge. That's
yeah.
Most of the VMs are huge.
Yeah, but you can choose. But on iOS, we only have duct tape because modern jailbreaks don't allow us to run V8. But yeah, basically that's true.
Right. So one of the things that we talked about was, or sort of advertised in the talk title, was to look at proprietary protocols. So there are a lot of these things happening, especially in the mobile phone space. So we'll show you a little bit of how Frida could help out in such a scenario.
So one example app is Snapchat. It does some encrypted communication. We can use a tool called Frida PS to list processes, and U here for USB. This is my phone, and A for applications, and I for installed. If I just run this, you'll see all the apps that are installed on my phone. And one of them happens to be Snapchat, this one, with this ID. So we can then use another tool called Frida Trace. U again for USB. F to say that we want to spawn an application from the beginning. And I should also show you the phone on the right here. I happen to know that this application uses the SSL read and SSL write APIs. And I forgot, yeah. So you'll see it launched the app, and you saw some SSL write and SSL read calls that happen here. Okay, so Frida Trace here doesn't actually know anything about these APIs. But we can tell it what we know about them. So if we went on the internet and Googled SSL read, we would find Apple's documentation, and we would then figure out what this API looks like. But there might not be any documentation now. We could do guesswork or use other reverse engineering techniques like tools to figure that out, like Radar. But here we are lucky, and there's documentation. And because we don't have time to actually go through all of the code we're going to write, I'm going to cheat a bit. And if you look, now I started the Frida Trace in this directory, and there's a handlers directory generated with one subdirectory per library that it found functions inside, and there's a security directory there. And there's SSL read.js and SSL write.js. So it generated one file per function. And we can go ahead and just open one of them and have some comments explaining the APIs. We can remove those because I'm going to just explain it anyway. But basically what you're left with is this. So on enter, this code is run before the function, when the function is getting called. And on leave is when it's returning. So you can do things before and after. So we could just change the message here to add hello, and you'll see it instantly. I saved the file, and the code on the device got updated. So now you see the new output. If we look at the docs, well, we'll see that there's a data pointer, the data length, and this one, when it returns, it will actually write to that buffer. So now I'm going to cheat a bit and then I'll show you a finished version of the code that I'm going to write. So what we're going to do is that on entry, we're just going to store the buffer pointer, the data pointer, and the pointer to how much was read. And then when we leave, when we return, we're gonna get the return value, and if it's 0, meaning success, we're gonna read the data, and then we're gonna do a hex dump. So if I save this, and here we go, you see a hex dump of the every time SSL read is called. So now we see the clear text of the encrypted communication. And similarly, we could do the same for the write function. And it's the same kind of API, so I'm not going to explain. And if I now tap around in this GUI, so you can see some SSL write here, SSL read. So you can then get an insight into the protocol of this application, that this application is talking. And then you can implement your own Snapchat client for Linux, for example, Linux, and do all sorts of interesting things. Or you could change this app to behave differently, remove functionality you don't want, and so on. And if writing these kind of scripts seems hard, there's a website I should mention, CodeShare Frida RE, where people can share their Frida instrumentation scripts and discover existing ones, and so on. So that's like a community-driven thing where, you have examples. So that was the first demo. Mm-hmm.
So I could work with, for example, encrypted WebSockets through the raw data.
Yes. Yeah. So you can see them.
That's something I've been having issues with. For example, man-in-the-middle proxy doesn't do WebSockets too well.
Right. Yeah. So the question was, can you use this to work with encrypted WebSockets?
Yeah,
yes.
For example, WebSockets.
Yes. And you can.
So you just work with the binary data directly.
Mm-hmm. Yes. So it's. I mean, if you've played around with aspect-oriented programming at any point, this is sort of giving you the ability to do aspect-oriented programming in binaries. So you, as long as you know a little bit of the structure of the program you're looking into, you can decide where in the call chain you want to hook into and inspect all the arguments that go into and out of those functions.
And as you saw, when we were playing around with that game, that was written in Objective-C, and Frida has an API to interact with Objective-C classes, and there's also one for Android for Java, so you can interact with Java APIs and do the same kind of things. And people could write additional runtimes integrations for Python, Ruby, Perl, other runtimes, which could be used to write like tools for going into server-side components and looking at their state and instrumenting them.
Do you rely on the developer's access or mode for Androids?
Not necessarily. So you could have a root on Android. You could have a rooted device. Then you could just run Frida server, one binary to transfer, run it as root, and then you have full access to the whole system. But if your phone isn't rooted, you can always repackage the app. But then you have other issues because the app might check its signature and so on. And then you could defeat those things with Frida, but there's more work. So you have several options. So, another thing is that you might want, I'm going to show you now, an application on my Mac here, Twitter. So one thing that's usually interesting is to know which kind of files an app interacts with. There's a lot of APIs it could use for that, but let's just do an example here. So the open, what's it called? So when it's called, we know that the path is in the first argument. So that's like this. Open called path equals path. And if we run this, into the Twitter app here, you'll see open is called a bunch of times if we just play around with the GUI. But here we just see the pointer. That's not very readable. So we can use another API now to memory read UTF-8 string. It points to UTF-8 string, and there you go. And now we're showing you the files. And you can already see that this application is using Crashlytics from the files it's opening. And you get some insights into the application. And then you might go on and explore further and where was this called from? Well, there's an API thread backtrace, which gives you a backtrace. That's just an array of return addresses. And then you can map that array of addresses to debug symbol from address if it's available. And you can join these by new line and tab, just make it pretty. And here you go, you see that open was called, and the caller was get directory URLs and core services internal, and so on. And there's NS file manager here, okay. So then you learn a bit more, and then you could Frida trace that Objective-C API, and then you can keep digging and exploring and finding out things about the application. And for fun, just as I showed you earlier, you can use you can interrupt with Objective-C APIs. So what we could do here is that we could use Apple's speech synthesizer and to just speak the name of
/library/preferences/com.apple.security.plist
to speak the names of the files being opened.
/user/applications/application/users/oleavr/containers/com.twitter.mac.
It's enough. It's not very useful, but it's just to show you that you can integrate with existing APIs very easily because you're running in the context of the target application. You can do anything it can do. Right. So another thing is on mobile, you might have, if you have a jailbroken iOS device, you might have seen this thing here. I'm just gonna try to start an app, but it says, hey, this application is not supported on jailbroken devices. There's a lot of ways this can be implemented, but we have just taken a quick look at this particular app. And it turns out that they have an Objective-C method called isJailbroken in the utils class. Actually we need to figure out the application ID, and that's flips here like this. And I'm gonna show it side by side here. So we'll spawn it and we're gonna trace this one. And you can see that it's called very early. Okay, so what we could do then is that we can use Frida's Objective-C integration to do our C classes utils. And there's a method isJailbroken there, so we're just going to get hold of that method, assign it to a variable, and then we're going to do isJailbroken.implementation equals, we're going to replace the implementation. Okay, Objective-C implement isJailbroken, and give it a JavaScript function, and we're going to return false, and we're going to just console log jailbroken. Nah. So again, I forgot the ID. It's this. Okay, so we can do Frida, USB, the app ID. We're gonna load this fips2.js, and we're gonna just continue after it starts, so we don't stop there. And if you pay attention now, is jailbroken now, and the app starts. So we have bypassed the jailbreak detection. But this was a very we spent just a few minutes reverse engineering this app to find this method. So it's not really a generic approach. So now if we tried, for example, the Mario app, Mario Run game, and spawn that. Pay attention on the right there. You're gonna see that it just crashes because it detects that the jailbreak, that the system is jailbroken. Interesting. And I had a look at this app, so I know that they are checking with lstat for different files, or indirectly checking with this. So if we trace that, you can see that they lstat applications Cydia app, applications rock app, user sbin sshd, user bin sss. Yeah, so you can see where this is going, what they're doing. They're just checking for a bunch of files, and then we could edit the code, and that's in the libsystem kernel lstat, and what will be interesting here is where is this called from? Okay. Called from so we do the same thing we did earlier. Get a backtrace. Oops. Yeah. Okay. Can try that. So here we go. We can see that it's calling this. It's actually not calling it directly. It's calling. Let me see. Look for Cydia here. It's actually using foundation, and as file manager, file exists at path, which calls lstat. So you could then choose to go to the Objective-C there and sabotage there, or you could go lower level and sabotage the lstat. But it turns out this application has more than just these checks, so we're going to have to spend some time doing a full bypass of this one. Or we could spend some time reversing the actual app and just finding the high level is jailbroken, if they have such a thing, and cut it out there. But then we don't write a generic bypass, so it's not really useful for other apps. And then lastly, another thing, we might have used the YouTube app on iOS, and it's kind of annoying because, well, not in this, well, I was lucky, but you're very likely to get some ads. Yeah, there's an ad, and those are annoying. So what we could do with Frida is we spend a bit of time reverse engineering the app, which has already been done here. So it turns out they have an Objective-C class called YTI player response, and it has a method is monetized. And if we replace that method and just return false, because it's not monetized, this particular video, well, then let's see what happens. So the ID of the app is this. So Frida trace, no, not Frida trace, Frida. I'm gonna load the YouTube script I have here, and you can, yeah, okay, percent resume. So if I try to play something now, it's calling, it's monetized 3 times, as you can see. There's no ads yet, and there won't be, hopefully, for them at all. So we can just keep playing, and yeah, no ads. So just 8 lines of code, or 9 lines of code. We had an ad removal for YouTube. We don't remove all the ads, only the pre-rolled ones. So, and then you could repackage this app and run it on a phone without a jailbreak and so on.
Right.
So,
Oops, sorry.
yeah, that's right. So, as you can see, there are a bunch of things that obviously you can do with Frida that's useful for doing, what should I say, nicer interoperability. But there are also some other applications that we didn't show you. Lack of time, lack of a bunch of things. But one of the things, for example, you could play around with if you develop your own apps, or if you want to see how your system handles situations is, for example, when it comes to networking, there's a long list, but emulating captive gateways, that's a situation you have to deal with if you're a mobile developer. And you might have a bunch of third-party libraries that you've been forced to use. For example, the ones that come from your OS that you don't trust all that much. So you can trace into those, and you can even write test cases for those to see that they don't change over time. And you can fake a bunch of, in principle, you can fake a bunch of data in the frameworks that don't allow you to fake data. So in principle, you could fake camera, microphone, motion sensors. You could do it for your testing, or you could even use it to track down the apps. So for example, if you have an app that really insists on reading your address book, such as Dips, and you don't want them to know all your friends, or Facebook Messenger, which actually takes a snapshot of your address book contact list and just loads it every time it starts. Not a great thing, right? Used to do that anyway. Then you can give them a short list or a fake list. It's also possible, since Frida is multi-platform, to play around with sort of cross-framework and cross-platform workflows. So for example, if you want to have some sort of SMS functionality, it's in your app that you're developing, or if you want to toy around with it, then usually when you hand off the text that you're going to give to the SMS subsystem on your phone, you can't do anything. They do everything behind that. But here with Frida, if you're so inclined, you can actually dive into those kinds of things. You can simulate things like resource starvation. What happens if you don't get enough memory? So it might not always be so easy to simulate these things yourself, because the framework doesn't allow you to do that. But with Frida, you can selectively hook into the memory allocators, those kinds of things, and really crunch on your own app or somebody else's app to see if there are any sort of holes or vulnerabilities that you need to think about. And finally, of course, time. So you can play around with the time and understanding of the dates and times in the app, and you can wind forward and backwards in the app while it is running and see how it handles that. For example, could you conceivably reset the ticketing system on the mobile phone and have the sort of ticker go backwards? There are a bunch of things you can play around with, clearly, responsibly, of course. So I guess the take-home message here that we want to emphasize a little bit is that we like open source, of course we do. But even if you don't have open source, if you don't have the source code, it doesn't necessarily mean the end of the world. There are a bunch of tools. Frida is just one of them. We like that one really well. But there are other tools as well that can help you dive into the system. So Frida does a lot of reverse engineering dynamically. It does it on the app while it is running. If you have you need to dissect something while it's dead, when it's not running, there are other good tools for that. Radar comes to mind. But in all these scenarios, I think we have to remember that there is clearly a continuing battle ongoing. So all the things that we showed you with Frida today might not work in 5 years' time, 3 years' time, because there is always changing sort of closeness going on in these platforms that try to battle the sort of this inspection facilities that we play around with. And I guess for your own projects, open source projects, I hope, you can use Frida to inspect the binary blobs that you sort of depend on. Either you depend on it because you're running on a closed platform, or you're forced for some reason to use closed binary blobs for your software to interoperate with other things. Then you can use Frida to inspect into these in certain situations. And that's the last one is probably a minor point, but you don't necessarily want to put logging all over the place in your application upfront. If you have tools like Frida, if you can design hooks into your system where you can introspect into it while it's running, that's also an alternative. I guess the flip side of that is that if you ship something into production and you need to debug it and you didn't put a debugging statement in there, it is actually possible to retroactively get at that with Frida. So I guess that was basically what we wanted to tell you today. Frida is an open source project. It's available at frida.re. We have a IRC channel on Freenode, and there is even a Twitter account where we tweet at people. And you're welcome to join the project. You're certainly welcome to use the project, and any feedback on Frida and sort of usability for you guys, from you guys, would be great. So I think that's it. Question?
I have a remark and two questions. First, thanks. I think it's extremely useful, and it would be a very powerful tool to try to fight some of this proprietary oppression we have in front of us. The remark is, you may want to ask your audience before taking their picture with some very crap.
Yeah, sorry, I discarded it, by the way.
Yeah, some people may consider it a little bit offensive or anything, but it's...
Sorry.
The two questions is, one, are you aware of any initiative that would somehow collect and centralize this information about what these proprietary apps are doing, or even the free software one, I think of Signal, for instance, that collects, like Facebook, all your address book and sends it to a server upon first connection? It would be extremely useful that people could browse the popular apps and say, oh, this one is doing this and that shit. No? That's my first question. The second one is, I have the impression that with whatever mobile, we're always running this uphill battle where shit is flowing down from the upstream, and whatever we do, we're somehow captured. The best example for that is the basement chip, the second computer within the computer. Is there any way that with Frida you would access to at least some information what is actually going on in that other computer?
So yeah, right. So the first question, is there a centralized registry, as it were, of data that gets collected by various applications, especially on the mobile side? I'm not aware of any.
No.
It's a great idea. Absolutely. Somebody should make one.
We're building a commercial one at the company I work for, but I'm not aware of any open at the moment.
And the second question?
About the baseband.
Was about a baseband, right? So in all mobile phones there is a proprietary baseband that takes care of all the 4G, 3G sort of mobile phone communication, and that's usually extremely closed. And the question was, can Frida reach into that and see what happens on the inside? That is tricky.
Yeah, depends really on the baseband, of course, but there have been people using Frida on embedded systems. That's actually why it was ported to QNX. Someone was using it on a car to figure out what they're doing there, or find security holes in a car. So I think that's a future. I hope in the future we'll have many more such targets, embedded targets. But for now, we're mostly running on desktop and complicated. High level, full-blown embedded systems, not low-level embedded systems. There's been some people using it on routers as well, though. But baseband, no, and not the kernel yet. But I think that's inevitable in the future that we'll go there. And I should mention one example that's very recent. There's a community that's reverse engineering the DJI drones. And they're using Frida right now to change the iOS app to. They're going to remove some phone home functionality, and they might also run it on the drone eventually.
Yeah, but for the baseband, I don't think we're aware of anybody using Frida to attack that.
No.
There must be somewhere in the OS where communication is established by the baseband, where you receive commands.
Yes, that is true. In many phones, it sort of works like a modem. But then you would be actually looking for a vulnerability in that communication channel, because you have to inject yourself into the other side where the baseband is running. And the baseband usually isn't running an OS that any of us are used to. It's a whole different planet, as it were, and it's very difficult to get a hold of baseband firmware in the wild to understand what's going on inside of it. There's been a series of talk on these reverse engineering basebands on the CCC conference almost every year. Yeah. So that is ongoing. I mean, as I guess from the Frida's perspective, is that once the understanding of that has progressed far enough that we can add support for it, let's.
Yeah. And the closest thing you can do right now is that you can, if the process, say on an iPhone that talks to the baseband happens to be in user land, you can always go into that process and start sending commands and then trying to fuzz the baseband, make it crash. So you're able to do that kind of stuff if it's running in the user land. I didn't look, so I don't know what it is.
Another question?
What is the legality of sharing workarounds?
Oh, right, yes. So how much is protected by free speech? How much is protected by... so I think, and how much is protected by sort of trade secret things? So I think the short answer there is I'm not a lawyer. But in general...
is there an initiative to share these where you can consider yourself a lawyer and just employ the ones that you want?
Well, so I think I think there will be other talks about these kinds of things later, where we can discuss that in more detail with people who are professionally employed as security researchers. And the security researchers in general claim, so the status quo is that there is something about this divulging security vulnerabilities responsibly, and as long as you follow sort of some responsibility divulging strategy, then you have pretty good leeway. But in general, if you're just a random hacker without no sort of credibility around you, especially if you're a younger person, there is a likelihood that somebody will see the opportunity to not necessarily assume the vulnerability that you divulge and look at it as a good thing, but rather go after you personally to discourage other people from doing the same. So yeah, that's more of a social, ethical, legal situation. Yeah.
Yeah, or give you a choice. Make you an offer you cannot refuse.
Another question?
Kind of a parallel to talking about basebands. What about proprietary blobs when it comes to GPU drivers, for example?
Right.
Mostly x86, x86, 64.
Sure. Yeah. So Frida can be used for those kinds of things. Many of these blobs are depending on what you're looking at. So there's.
You can usually extract them, but reverse engineering them for example, x386 is a problem.
Yeah, absolutely, indeed. So porting them from one architecture to another is a problem. Porting it from one windowing system, for example, to another is also a problem. And Frida cannot, unfortunately, invent structure and information about this blob that's not there. It's useful for giving the ability to inspect into the process while it is running. So that sometimes gives you a better idea of how things work, because you can reverse engineer it by looking at the state that it changes on your computer and not just simulate all of it in your head. So it's a nice addition to the static reverse engineering tools.
Yeah, I would recommend Radar there for static, so you can look at it and then you can validate your assumptions if you're able to inject Frida into. If the blob happens to run in user space, you can inject Frida, and then you can hook any function and see look at the arguments. And then you could do something with if it's a graphics driver, you could write a test application that does certain things.
You should be able to attach to the actual process the kernel worker as well.
Yeah.
We usually loaded as kernel modules.
Yeah.
Yeah. So in the future when we support kernel mode injection, we'll be able to do that, but not right now.
Okay. Thank you for listening. Yeah.